The Earth's axis has a tilt of 23.5 degrees. Thanks to this tilt, we observe the change of seasons every year. In our hemisphere, it's hot in the summer, the days are long, and the nights are short. In winter, despite the fact that the Earth is closer to the Sun at this time, due to the tilt of the axis, the northern hemisphere receives less heat and it becomes cold. In the southern hemisphere, everything is exactly the opposite. But why is the axis of our planet tilted, and why exactly at 23.5 degrees? How did this happen? Was it ever different? We will try to find an answer to this question. With you is the Epoch of Mistrust channel with Mikhail Kalmykov. I'll say right away that 23 whole and 5/10 degrees is the average accepted value. In fact, the tilt of the Earth's axis fluctuates between 22 whole and 24 whole and 5/10 degrees. Such fluctuation is called precession. The very fact of this fluctuation, we have become accustomed to the fact that the Earth stably rotates at a certain angle. We have become accustomed to the change of seasons. And some kind of strange order of things makes us seriously worry. Official scientists assure us that it has always been this way, that the culprit of the tilt is the moon, and that it is precisely thanks to the change of seasons that life appeared on the planet. However, common sense sees clear inconsistencies in these statements. Well, first of all, if life appeared precisely because of the change of seasons, then where did it come from at the equator? In India, in Africa, in Mexico, or Brazil at the end of the day? After all, there is a sufficiently mild climate there and no sharp weather changes. Regardless, make it unique. Secondly, according to the statements of the same scientists, the first life is something unique. Secondly, according to the statements of the same scientists, the first life appeared in a water environment, in oceans, which thanks to the properties of water, do not freeze to the bottom. In a liquid state, water in rivers and lakes does not drop below +4 degrees. And the deeper the depth, the less the temperature fluctuates. At a certain depth, the water temperature never changes. And yet, there is life there, and what a bustling one at that. With what purpose do scientists try to instill in our subconscious from school the dogma about the vital necessity of changing seasons? Nevertheless, we know from the same scientists that the Earth has repeatedly changed its poles and the tilt of its axis. This was found out, among other things, by studying the hardened lava of ancient volcanoes. That's why geologists relate the change of poles to the distant past, millions of years away from us. However, it's not that simple. Now, it's no longer a secret that many ancient structures are oriented towards a different pole, towards its other location. Some old maps also speak about this. In the year 868, Carl Friedrich Mohr released his History of the Earth, with geology on new foundations, often demonstrated on alternative channels with the phrase "in the present time." Geology occupies a place in the row of exact sciences. The number of individual works from which it consists is immeasurable. The collected facts are as numerous as they are well researched. And some are of a very high degree because they explain the original state of the Earth. They are of a very high degree because they explain the original state of the Earth's sphere and the terrifying upheavals it has experienced from time to time. But few know that in the same work, he blew to smithereens the works of the British geologists Sedgwick and Murchison, already familiar to us from the previous series, proving that the so-called Paleozoic rock formations, Silurian, Permian, Carboniferous, Devonian, Cambrian, as well as Cretaceous and all others in which fossils are found, do not testify to the age of the rocks about their deposits over millions of years. Moreover, they continue to be deposited right now. And in just a few hundred years, some riverbanks will turn into Silurian and Devonian cliffs. And geologists date them to millions of years. Moreover, unlike Sedgwick and Murchison, Karl Moore knew what he was talking about, as he was a practicing chemist who made a lot of inventions in chemistry. But let's get back to the Earth's axis. Oil in the fire adds an interesting effect, popularly called the Dzhennebekov Effect. First discovered in 1985 by astronaut Vladimir Dzhennebekov, this effect simply hypnotized everyone who saw it for the first time, including me. I remember that in weightlessness, a nut unscrewed along its axis would suddenly flip 180 degrees. Then it flew for a while, spinning, and then suddenly flipped back the same way, and so on to infinity. Then the idea came to see what would happen to the plastic ball under such conditions, which was immediately implemented here. The astronaut sculpted a ball out of plasticine, stuck some kind of nut on one side, and started spinning it. And miraculously, the ball began to behave exactly like the nut on the lamp, that is, periodically turning over by 180 degrees. And about the Earth's rotations, it must be admitted that the scientific world was also about the Earth's rotations. It must be admitted that the scientific world was quite perplexed by this discovery. However, everything became clear in the 1990s. And it turned out that, one way or another, this effect was already known quite a long time ago, more than 100 years. However, until people went into space, its manifestation in the conditions of Earth's gravity was not so noticeable. In space, however, this effect revealed itself in all its glory. Now we know for sure that the so-called intermediate axis of rotation is to blame. I won't go into details. There are now programs where you can model the behavior of an object and its rotation yourself. And the video is not about that. The main thing is that nothing threatens the Earth. Well, first of all, because for a planet to flip over, there needs to be a serious difference between the three main axes. Remember the experience of Dzhennebekov. In order for the plastic ball to flip over, he attached a heavy nut to one side, significantly shifting the center of gravity. Secondly, the planet has long been in a balanced state, and the excess energy caused by the masses of matter is insignificant on a planetary scale, and is also expelled with the help of the same volcanic eruptions or earthquakes. And thirdly, if the Earth was really subject to this effect, we would see this movement of the axis across the Earth. It would move along an ever-increasing spiral until it flipped over. However, we do not observe this. No, of course, there is a process, but it is unstable, unpredictable in the long term, and apparently caused by other processes, or a combination of a huge number of other processes. Nevertheless, the fact of the shift in the Earth's axis of rotation is there, and you can't get away from it. Another hypothesis, also quite popular among both scientists and alternativists, is the theory of lithospheric shift. One way or another, it is associated with the Earth's collision with other celestial bodies. This hypothesis looks quite attractive, but judge for yourselves. The lithosphere, together with the mantle and oceans, is literally a solid cork on a sphere of hot liquid magma. A meteorite or asteroid colliding with Earth transfers energy to the lithosphere, causing it to break for a short time. During this time, the rest of the planet continues its rotation, and as a result, the Earth's lithosphere would literally slide over it, shifting relative to the planet's overall rotation. Despite the apparent beauty of this theory, it also does not withstand criticism. Judge for yourselves. Firstly, the area of intersection of the lithosphere with the internal magma is colossal. It is essentially equal to the entire surface area of the Earth. The area of intersection of the planet with the meteorite in this case is negligible. Even if the asteroid is hundreds of kilometers in diameter, it's still far too small to overcome the resistance of the lithosphere's tensile strength. Any meteorite is more likely to pierce it or vaporize upon impact than to shift it. The mass and area of the lithosphere are incomparable to the mass and area of a meteorite. Try to shift a bulletproof vest sideways with a pistol shot. And not a piece of the vest that might get hurt, but the whole bulletproof vest, so it would turn around its axis. The analogy is roughly like this. Even if you completely exclude the force of friction, the mass and consequently the inertia of the lithosphere is still colossal. Even if you imagine that the lithosphere somehow still slid to the side, it still wouldn't affect the overall axis of rotation. The whole system, a huge gyroscope under the name of planet Earth, still continues to rotate around the previous axis, even with the shifted position of the continents. Apparently, that's why scientists accept the version of the ancient collision of our planet with a huge celestial body, possibly another planet, as a result of which a piece was torn off from the Earth, called the Moon, simply because the mass change required for such a change is colossal. To understand this, you don't even need any computer models. Experiences with rotating bodies in orbit show that no matter what force you apply to the gyroscope, it will not change its axis. It will deflect to the side while maintaining the stability of the axis position. Yes, you can actually convince yourself of this. Spin the wheel and hit the axis. In order for the axis to lose stability, the wheel must either slow down the rotation or the hit must be delivered by a body much more massive than the wheel itself. Nevertheless, the Earth's axis does precess. Many also explain it using the example of a spinning top. But in this case, the comparison is inappropriate since the spinning top is on the ground. In its upper part, the axis, the North Pole, so to speak, rotates freely, while the lower one, the South Pole, is stuck in the ground, a stand, something in the base. And when you hit the spinning top, the poles shift unevenly. The North Pole moves freely in the direction of the blow, while the South Pole experiences resistance from contact with the Earth. As a result, we get precession. In space, there are no supports for rotation. The body, having received a blow, moves uniformly. There are no friction forces, so the planet or object will simply shift entirely in the direction of the blow, but the angle of the axis will remain unchanged. Yes, in one of the previous videos we tried to change the axis of rotation of a similar planet, Venus, by bombarding it with asteroids. And we even managed to do it. However, in the process, the planet itself, its surface, was destroyed and turned into the hellish wasteland that it is today. So, this method is not suitable for Earth. In other cases, the gyroscopic effect from the planet spinning around its axis always interferes with changing the angle of rotation. So it turns out that there is no exact answer to this question. Or is there? The one who hinders us can help us. For a full understanding of the process, let's start in order. Let's start from the very beginning once more. Let's recall how it happened that planets rotate. According to the generally accepted dogmas, the rotation of the planets originated at the dawn of the formation of the solar system, when the Sun and planets were formed from the protoplanetary disk. During further formation, the outer edge of the planet, the one further from the Sun, rotated and still rotates somewhat faster than the inner one, the one closer to the Sun. Accordingly, the densification of matter proceeded in the predetermined initial direction. The ever-increasing mass of the planet, accordingly, increased its gravity, forming such a three-dimensional vortex, the direction of rotation of which was determined by the same initial direction of rotation of the protoplanetary disk. Of course, in reality, there are other theories of planet formation, but in this case, we are interested in the fact itself. Initially, all planets formed their rotation around the Sun and around their axis on one plane, simply because such a position is the most energy efficient. This plane is called the plane of the ecliptic. And in the end, each planet took its place on a kind of two-axis gyroscope. The first gyroscope is the planet itself. It rotates around its axis and thus firmly holds its position. The second gyroscope is the planet's rotation around the Sun. This is also a gyroscope, but of much larger dimensions. That is, one gyroscope inside another. The system is stable enough, and little in this world can change the angle of rotation. No collisions with asteroids in any case can. Moreover, after the formation of the planets, all objects in the system occupy their most energetically favorable positions. The system becomes stable. Not only planets, but also asteroids, comets, and large and small meteorites. Everything in this system moves evenly around a single center of mass. And even the possibility of an asteroid moving from its location is unlikely. Objects in the Kuiper belt and in the Oort cloud and in the asteroid belt all move in their orbits. There are no forces within the system capable of causing chaos. Nothing within the system can affect the established course of events. The very possibility of the appearance of extended orbits is now unbelievable. Even if once in 1,000 years a random asteroid flies into the solar system, it will almost certainly fly past the planets without hitting anyone. The system is so large and the asteroid is so small that it effectively reduces this probability to zero. Nothing can disrupt the proper course of things and order. Nothing inside but not outside. Imagine our planet, a kind of gyroscope, a spinning top set on a rotating disk. This is the flatness of the ecliptic. The spinning top maintains its position on it and the angle of the axis tilt. But try to change the angle of the flatness itself. In fact, our planet's gyroscope will maintain its angle. However, relative to the flatness of the ecliptic, the tilt angle of the planet's axis will change. In other words, for the Earth's axis to change its angle without devastating asteroid impacts on the planet, the angle of the ecliptic flatness needs to change. Sounds fantastic. Indeed, the change in the angle of the ecliptic flatness should be immeasurably greater. The force to change the angle of the ecliptic flatness should be immeasurably greater. The force should be simply colossal. However, let's look at the current state of the solar system. The planes of the orbits of absolutely all planets have an angle of inclination to the general plane. Some orbits are elongated. And the further from the Sun, the closer to the edge of the system, the more chaos. Forget the planets, the Sun itself has an angle of tilt of its axis to the general plane of orbits. What force could have done this? Well, for example, an object equal in mass to the Sun, or even bigger. We immediately discard the second star, given that within 1 to 2 light years of us, it simply does not exist. Then the first thing that comes to mind is a black hole. Seeing it directly until it goes into the active phase of matter consumption is impossible. But it can be calculated by the traces. Let's try to model the situation. We will set the flatness of the orbits of all planets in the solar system to their initial position with a deviation of 0 degrees from the general flatness. We will also set the tilt angles of the axes of all planets to 0 as well. We will also correct the eccentricities of the orbits to 0. We have obtained an ideal system, one that it should have been after forming from the protoplanetary disk. Now let's add a small black hole to the simulation with a mass, for example, of 1 Sun. And let's launch it past our system at a speed of 50 kilometers per second. This is a normal speed for interstellar space, even a small one. To such a speed, let's launch the simulation and see what happens. We're starting at such a speed. We're launching the simulation and seeing what happens. We're starting from a distance of about 180 astronomical units. Our wormhole should fly close to the solar system, practically through it and slightly above. As we approach, we see how the wormhole's gravity begins to shift the orbit of Pluto, then Uranus. As we pass through the system, the orbits begin to wobble like a top. The flatness of the ecliptic changes, and accordingly, the tilt angles of all planet axes change. The light show continues until the black hole leaves the space of the solar system. Meanwhile, the hole itself is not even visible. Now let's look at the result. Inside the radius of the planets Earth, Venus, Mars, the changes in the flatness of the orbits are minimal, but the further to the edge of the system, the more chaotic the result. Compare with the current state of the planets of the solar system. The resemblance, as they say, is there. The orbits of some outer asteroids, especially beyond Pluto, are stretched so much as if someone tried to rip them out. Of course, there are some uncertainties. Well, for example, why, if the angle of inclination of the plane to the leaf of the Earth is 7 degrees, the inclination of the axis is not 23½ from the moment of the black hole's departure, when the Sun was again shrouded and passed from the moment of the black hole's departure, when the Sun again turned to the most energetically advantageous orbits, that is, as close as possible to the overall most energetically advantageous orbits, that is, as close as possible to the general axis of the ecliptic. Most likely, the current general flatness of the ecliptic of the solar system does not correspond to the previous one, and only the gyroscopic planets retained information about the position of the old flatness of the ecliptic. Nevertheless, no matter how catastrophic our black hole's passage was, it moved at a very decent speed, more than 50 kilometers per second towards the Sun, at a very decent speed, more than 50 kilometers per second towards the Sun. In a few months, the black hole left our space and moved on. However, this was not the end. It was just the beginning of the catastrophe. From that moment on, a countdown of events began that engulfed the entire solar system in a wave after a few decades. If you imagine that there were civilizations and developed planets in the solar system at that time, then from that moment, they had a limited amount of time to prepare for the consequences. Countdown to the end of the world. The time during which they had to throw all their efforts into preparation in all directions, considering all possible consequences up to the most nightmarish ones. Prepare for survival. Create bunkers, shelters, knowledge repositories. Develop a strategy for restoring civilization after destruction of any level. Think through a plan of action for recovery hundreds of years in advance. This was the beginning of the disaster, but the disaster itself was ahead. Hundreds of years of consequences. But more on that in the next episode. Friends, none of us are afraid of mistakes. And if you see a flaw in my logic, don't hesitate to leave a clear, articulate, and angry comment under the video.